Welcome back. And we finished our discussion on molarity and molality, right? And the third thing that was on the list was percent by mass, okay? And the actual definition for it is mass of solute divided by mass of solution, okay, times 100%. Now, the way I have written it is, it's actually the percent by mass of a solute, because you will see quickly when I say percent by mass of solvent, you'll see it's exactly the same, just the numerator will be different. So it's mass of a solvent divided by mass of solution. This is probably the easiest of the things you have learned the entire term, okay? And so maybe I spoke too early about the molality being the only question on the test. I think most of you probably would request, can you make 25 of this on the test? And again, the answer is no. However, I do appreciate your optimistic attitude in that case. So percent by mass of solute, percent by mass of solvent. And I think in chemistry, just like any other term, it will only make sense when we actually put it in the context of a problem, right? So here is the problem, okay? What is the percent by mass of 5 grams of iron 2 sulfate dissolved in 75 grams of water? First, you gotta decode the problem and write it in a way that makes sense to you. Now, this is the way it makes sense to me, and so I'm gonna write it up. First, don't read the problem a couple of times and write down what is given. Well, I'm given iron 2 sulfate, and I'm also given the mass of water. Okay, I've told you repeatedly, water is the solvent. Water cannot ever be a solute. I don't see the purpose of it. And iron 2 sulfate is a solute. All right. Test of your week 3 knowledge of writing formulas out of a given name. Now see, again, we are tying back to everything we've learned prior to everything we will learn or learning. So iron 2 sulfate. Okay, some of you, again, the reason we're doing this over and over again, multiple different ways, is so you get the idea. Iron 2 sulfate. Okay, you gotta first figure out the formula, otherwise this problem is a no-go. At least if this was the case in a molarity or molality, you probably cannot do it at all if you don't know the actual formula of this iron 2 sulfate. Maybe not so much for percent by mass, because you won't be doing any conversions. But I do want to take the time to write the formula for it, even though it will not be used. So iron, the 2 is stacked to the iron, so it's iron and 2, and iron is a metal, so it's plus, and sulfate is a polyatomic ion, right? So we write that in bracket when we are finished. So 2 comes here, this 2 comes here. Well, they're both 2, so there's no problem. But still, I'd prefer to write my sulfate inside the bracket. Now, in this particular case, because we're not finding moles of solute or moles of solvent, the formula itself will have no impact on the calculation. So that's why I said you would wish that you'll have this same problem 25 times repeated. So let's find percent by mass of the solute, which would be, let me get a different color, percent by mass of solute, which in this case, I am not going to write iron 2 sulfate. I'm going to write actually the formula, because I did spend time figuring this out. So that's my solute. What is the mass of the solute? It's 5 grams. What is the mass of the solution? Well, a solution is a combination of solute and solvent. There's 5 grams of solute and 75 grams of solvent. So mass of the solution is 80 grams. and then you divide each of them and then multiply it by 100%. Okay, and that would be 5 by 80 times 100, so that would be 6.25%. That's the percent by mass of a solute. Now you already figured out what would be the percent by mass of a solvent. It's going to be a large number. You can do two things. You can actually do the calculation, or if you've done the solute, subtract it from 100. 100%. Actually, you can do two things. You can repeat the whole calculation using the formula for the solvent, or you can simply subtract it from the solute. 100% minus 6.25%, which would be, actually I will do the problem in the other way as also. So 100 minus 6.25 is 93.75%. There's two ways you can do. If you've done one, you don't need to repeat the other one in the formula, but because we're here, I might as well show you that as well. So percent by mass of a solvent in the actual formula would be, well, we know the solvent is 75 grams, so 75 grams over the solution should still be 80 grams, and then you multiply by 100%, and that will be 93.75%. So these numbers should be exactly the same. Now say the question does not have you calculate the solute, then yeah, you would have to use the formula to get it, and then percent by solvent. If you already calculated the solute, you can just subtract it from 100. Keep in mind, I will not provide these formulas because I'm providing so much information in the remainder of the course. This is something you have to remember, okay? As I said, the calculating concentration is not just a scope for this class, but it has a larger purpose to anything outside of a classroom setting. All right, so we're done with percent by mass, and the only thing that is left is percent by volume. Okay. All right, I was just shifting screens, so let me go get my Midway screen here. Okay. I was just shifting screen and also shifting the formulas and equations, everything at the same time. So all right, if you have guessed, sometimes you can guess, right? Just like percent by mass, percent by volume would be percent by volume of a solute. Okay, solute equals volume of a solute. Again, for this to happen, we're going to look at one different case where it might be slightly, it will be tricky, but I will teach you that tricky one as well. But for now, let's look at the easy ones. Volume of solute divided by volume of solution times 100%, and percent by volume of solvent. Okay, solvent would be exactly the opposite. So volume of solvent divided by volume of solution times 100%. Okay. All right, let's look at the sample problem here. So let's go get a different color. What is the percent by volume of a solution formed by adding 15 liters of acetone to 28 liters of water? As I said, anything that's not water is most likely your solute, and water is your solvent. And you don't need to convert to milliliters or anything, use it as it is. Why? Because it's a ratio problem, okay? Volume of a solute, well, that's 15, so percent by volume of the solute, which in this case is acetone. I'm writing the specific name. That'll be 15 liters divided by the total volume of the solution is 15 plus 28. So that would be 43 liters. And you divide each other and you multiply by 100%. So that would be 15 divided by 43 times 100. So that is 34%. Okay, so that's 34%. Okay, and percent by volume of a solvent would be, as I said, if you've already calculated the percent volume of a solute, you just subtract 100 minus 34%, which is 66%. But if you've not done this, then you have to do the method that I like, the one I showed you earlier. You can do both, depending on which one you have before you do this step. If you don't have the step above, then you can't do this. You gotta go with the regular one here, this one. So volume of solvent is 28 liters. Volume of solution is 43 liters. And you multiply by 100%. So that'll be 66%. So these are the 4 basic concentration units that you have to know for not just this class, any scope outside of this class, and future classes you will take with me or somebody else or somewhere else. So you would need to know these. These are very, very fundamental. So the 4 things are molarity, molality, percent by volume, and percent by mass. So those are the 4 things we've learned. In the next video, I'll show you a couple of alternate ways of using this knowledge to a different area, all right? But that is in the next video. So I've covered all the 4 basic concentration terms, and then we're gonna have one more video on this topic. All right, so stay tuned.